Hello, Angel. We are live in Twitch.
Right. So I'm gonna share my screen. Make sure right slides. Share. All right. I guess we can start. Thank you very much for all being here. Welcome to the second, let's call it hybrid event of Cloud Native Asturias. We have today with us two amazing speakers, online and two here on site at the Empathy headquarters. First of all, thank you very much for having us. You have a really great building here, an amazing setup. I'm fascinated with the arrangement of cameras and microphones and all that. The video wall, it's super cool. Overwhelming to the point, to some point, because I'm a bit lost with all the screens, but it's pretty good. So thank you very much, really for having us today. Just a few notes on where what we do at Cloud Native Asturias. It's a non-profit organization. We are aiming at our objective is to elevate the Asturian technological landscape through worldwide collaboration. As you can see, we have speakers, international speakers, and local speakers from Asturias. We are three co-organizers. We have Andres here on I don't know if you can see him on the screen, but yeah, he's here with us. Hello, Andres. We have Marcos, who is another co-organizer. He's now currently in Madrid. My name is Andres, and we're driving this beautiful initiative that gives us the opportunity to meet great people from a professional point of view. Just a few words on the code of conduct. Please be respectful to everyone. Kind of things that we just be polite and yeah, respect the code of conduct. Before we start breaking news, we have now a Discord channel for Cloud Native Asturias. This is the QR code in case you want to join. We've set up this community a while back. We've been testing it. We have a little bit of a structure there. We hope that we could have that as a community to bring everyone together within the, let's say, technological space in Asturias, and also international speakers that we will bring along over time. Just if you could spread the word and help us to, make use of it, that would be very appreciated. Just a couple of seconds so that you can jump into the Discord channel. So for our international viewers, we know we have some, and for Bart, although I think he knows already about Asturias. Asturias is in the north of Spain. Right now we are about here around Gijón, and our plan is to over time to visit other headquarters so that we can engage with more professionals around Asturias, and hopefully over time also international speakers can come and visit us. This is the time it takes to come from a little, just to put us in the picture in the map. The time it takes to come from the Netherlands. And yeah, follow us on social media. We are quite active in Twitter. We have our Twitch channel in which we are streaming right now. YouTube channel, we are also streaming, and we're very active also in LinkedIn. So please follow us on social media. Just a brief agenda for today. We will start with David giving us a little introduction on what Empathy, our host today, sharing a little bit of what they do at Empathy. We'll continue with Almudena Vivanco, talking about the swag of performance testing. Then Hector will be here on site talking about MS SQL Server Azure Cloud Overview. We'll have a 10-minute break. Then we'll move to Roberto, which is going to talk about here on site as well, leveling up your Terraform workflow with GitOps. And last but not least, we'll move back to the online presentation with Bart. He's gonna walk us through his presentation title, Welcome to the Room, Bart. Without further ado, I guess I would like to give the stage to David. And yeah, please come along.
Thank you very much, Angel. Start sharing my screen. I think that we have enough security distance, so I'll take off my mask in case you don't listen me well. Okay, so I'll share my screen. I prepared some slides. Okay, so I have to start as you started, Angel. Thanking you all for being here and really celebrating that we are back to live in person or hybrid events. For me, it's the first time in 2 years that I attend to an event again in person. So it's time to celebrate. And thank you, Angel, Andres, and Marcos for this organization. And thank you, all the team at Empathy, for making it happen here at our offices. Mario and the IT team, Amplify team, thank you guys for making it happen. So my name is David Suarez. I'm the Director of Engineering here at Empathy. And I will, as Angel said, I will tell you a little bit what we do here and who we are. Just 5 minutes. I don't want to delay the swag of performance testing, which is much more interesting, definitely. But let me tell you a little bit. Let me introduce you Empathy. So we do here at Empathy commerce search builds for trust. So we do search and discovery components, software engineering products that are present in e-commerce sites. I'm pretty sure that all of you here and watching us in remote have used any of our components in some of your favorite sites. We do have customers that operate worldwide in very big Spanish companies in business like retail, fashion, or groceries. So definitely you have been in contact with us before. Let me start a little bit to tell you where we are, who we are, and what we do. This in the slide, you can see the office where we are at right now. This office is in Gijón, as Angel just said. We do have headquarters in London and in Galicia, in La Coruña. And we have embraced remote work, so we have colleagues all over the world, really. Our values is trust, understanding, and joy, and we really do that or we keep that in mind for everything we do. Any engineering, product, and also the way we behave with each other. We are human-centered. Our mantra is more human, and we try to extend that to everything that we do. We are at, I think today the count is 230 something, 35, 36, and over 150 are in engineering, research, innovation, and technology. So kind of like a 75% ratio. Another cool things that we have done, especially in the past years. Well, last year's achievements, just to highlight on the technology side, on the platform side, we have embraced and adopted Helm charts for our deployments. This is a practice that's already a standard in the company. We have also adopted the FinOps culture. Again, starting from the platform, but it is really a culture that is taken across the whole company. And we have used, for example, some open source technologies like Apache Spark or Flink in opposite or substituting some cloud provider or third parties services. That way we try to reach the cloud agnosticism. It's not only that we do technology, platform, cloud engineering, we also, on top of this, build software engineering products that really are applied, and this is probably what you have already experienced. Some cool features that we have released during last year. You can see here popular searches on the left and in the way that it helps the shopper in their search discovery journey. And also next queries, which is a help for the shopper to find and drive to the next step in their discovery journey when using the e-commerce site. That also helps, and we have tooling and capabilities for e-commerce admins or merchants to help and know much better their customers. So these are a few things that we have just released and innovated during last year. We are, and obviously we are very active in the community. We're hosting this event, but we have, at least for the almost 3 years that I've been here in the company, we have always participated in this Cloud Native events here in Asturias and all across Empathy. Robert today is speaking here, and we do have many colleagues speaking in this kind of events, not only in Asturias or Spain, but also in the last, for example, Kubernetes states in Guatemala or Italy. We always try to give back, and we do have, as you can see there in the slide, public repositories. Those two are very good examples. The first one, the X1, is our interface components for front-end engineer. The other one is the Kubernetes cost report that we have developed ourselves as part of our FinOps culture. So those are public and you can participate. These are in our company GitHub. So this is a lot of stuff that we do. We do much more. I hope it sounds cool enough. So guess what? Why don't you be part of it? Why don't you join us and become a colleague at Empathy? We do have open positions. We have grown a lot in the past 2 years, especially last year, and we do have great plans to grow this year. So join us. There are a lot of interesting positions, projects, and challenges, and much more to discover. Visit our website, the company careers side. You can see how it looks like to work at Empathy, what are the benefits that we have, our culture, and all the open positions that you can apply if you feel. So that's pretty much. Let's don't be strangers. Let's connect. We have our LinkedIn site for the company. You can follow there. We do have a very cool weekly live stream event in LinkedIn Live, where each of the teams each week present a new release or a new feature or any new project. We do have a Twitch channel where earlier this week we had a live coding presentation by our front-end engineering guys. And we have recently released our engineering blog. And I'm just realizing that the URL is not right there. So I'll share it in a minute. But it's basically engineering.empathy.com. So it's recently released. Our colleagues here at Empathy publish their posts about engineering. We are tweaking it because it's still been worked on in the look and feel, the designs and so on. It does have dark mode already, so it's pretty cool. Check it out. And on my side, yeah, let's connect. Find me on LinkedIn. Ask me about Empathy. Ask me about the open positions. Yeah, let's connect and let's share all our initiatives. Okay. So that's it. I'm not going to steal you more time. Thank you again for everyone. Thank you for you guys organizing. Thank you for all that made it happen here at Empathy. So one more thing, enjoy the day. Okay, thank you.
You're welcome, David. Thank you. Thanks. All right, now we have Almudena, who is online. While you share your screen, seconds. So yeah, thank you very much, David, for that presentation. Almudena is all yours. Yeah.
Yep. So hello. Going to talk about a bit of performance testing today. I know that it's not a usual subject, but it's a really interesting, and I hope it will be fun and easy for people. As I said, I'm called Almudena. I'm from Avilés, though I live in Barcelona. I work right now for Lidl. I'm a principal engineer there. I call myself Pringa Ops, and that doesn't have much of a translation because I Pringo mucho, so I'm the Pringa Ops, principal Pringa Ops there. So that's it. As well, I try to be advocate of women in technology, as you have noticed. And yeah, I work together with girls in tech sometimes. What I'm going to talk today, so performance testing, to make it easier. Usually when we start talking about performance testing, or when we start to talk about how we are going to implement performance in our companies, just a bit of people are scared of it. It's too difficult. We need a pre-production environment, all that stuff. What I will try to put together today is that actually it's really easy. If you start doing performance, it's to create the tests are pretty simple, right? If you have the current I don't know, but if you have a proper environment of coding, if you're working already with Open API, for example, it will be really easy. So hopefully everyone here knows about the Open API, but I will give a bit of insights in it. Open API has a specification. It used to be known as Swagger. Actually, I'm still old school, and sometimes I call it myself Swagger. We will be describing RESTful API, so we're not going to talk about, I don't know, but we're not going to talk about MVCs or any other kind of protocols. But right now, just the easiest way is just to describe the RESTful APIs, and that's the way that we are going to get to know how to performance test. So Open API, RESTful APIs, we are going to have these specifications in JSON or in YAML in our case. But it's a way to design, to share all the knowledge that we have while coding, right? And actually as well to visualize your APIs. That's a really good way to start. Why do we need that? Is that we need to describe it in a way that everyone understands within the team, not only the backend, but with all the front end of the developers, but as well the POs, the PMs, the QA, everyone within the squad or within the team should be aware of what is happening and what is the specification and what is the documentation of that code that we are developing. So Open API just adds you that layer of sophistication just to work to play with the APIs actually, because it's not that long ago that we have these static documents like a PDF with the API that it was like, oh my God, this is from the past, but this is like 3 years ago. Okay, we have this kind of PDF that it was running in Confluence or in Alfresco and in the documentation, and that is not growing, it's not changing. It's like a bit of the Stone Age, right? But this wasn't that long ago. Now we have this editor or this environment by Swagger, by Smartware, where you can work with the APIs. You can just make them grow, change them on the fly. That the documentation is in the code. That's a really interesting idea for me, and that's the basis of everything. What information do we have within the Open API specification? We have, of course, the general information. We have who has done that, which is the base path that the base URL that you're gonna use, the host, tags, just to well, like everything. What is the protocol that you're going to use for the API, the path, the methods, the model definition. You have almost everything that you need to know. I'm gonna change from here to here. So the thing is that you can work with, you can play with that API. You can just try it out within the editor of Swagger or the private instance that you have with Swagger. So you can just try it out and work with it, right? So everyone can show, I don't know, maybe the curl that they need, or what is the response headers, what are the details, the code, everything. That this is like a playground. This is a way to touch it. So the code is not only just something abstract. It's something that you can touch, you can work with. Okay, that's makes it easier for everyone. Back to the presentation. Okay, so why do we have this problem? Why do we need to Open API? I don't know you, but I have been working with microservices for some time now, and we have like a lot of squads right now in Lidl. Well, when I started 12 years ago in this microservices world, the Scrum world, we have, I was in InfoJobs at that time, and we were like 12 squads at that point, 12 Scrum teams, different squad teams. Right now in Lidl, I have like, I think that we are already 24, 25 squad teams. So the communication between them is just not between the code itself, it's not just the communication between the microservices, it's as well the communication between the squads. That is important. That's why we should use tools like Swagger, like OpenAPI, just to have the integration of all the microservices and all the teams calling one to each other. Okay. So you don't just share the PDF or a mail, just saying, well, this is the specification of your API that you need to call. That's, for example, an application map of a simple microservices within Azure. That it's actually the cloud environment that the cloud provider we are currently using. You can see all application maps in Google Cloud or on Amazon Web Services. You can just see it there. But all these microservices, what implies, where do we need testing? Where do we need performance testing actually? And that picture, I just drew it like 15 years ago. And it's actually currently it's the same. It's exactly the same. We need it everywhere. Every time that we develop, that we deploy, that we deliver a new package, we should have test not only performance, but testing in general. And of course, to deliver all that, to give the most of us to deliver the best quality code that we can have, of course, we need to automate. Everything needs to be automated, and you have to make it easier for developers and for everyone in the squad team. The problem is that usually as a performance tester or as a performance engineer, actually, or as a site reliability engineer, that is not my current job description. We are not that many. So we are like 1, 4, 5 or 6 squads. So we need to automate everything. We need to give the most of us. And automate, you have this useful and well, you have this Swagger OpenAPI specification where you can work with, where you can see the versioning, where you can see everything. And of course, as soon as as everything, as soon as if you test as soon as possible, you get the most profit out of it. So you don't need just to wait for the last version. You don't need just to wait to have it deployed in production. You can test it in your local. If you have a really huge performance issue, you will see it in your local. You will see it in your QA environment, in your staging environment. You can see it as soon as possible. That's the most important thing. So the point is just get your testing while you code. So it's not, I'm not gonna just say TDD. TDD is not the panacea. It's not the way of solving all the problems. But if you test as soon as possible, if you test as soon as you can, you will see the problems faster. And that's why I like this way of Swagger or OpenAPI. Why? Because we are able as well just to generate mocks from this specification. Of course, it's not the same. Performance-wise, it's not the same. If you don't have the code, of course, it's not the same. But you can create the tests as soon as they are delivered. So that's a way just to improve the process. Because, as I said before, I'm one performance engineer for 25 squads. So I will have a problem there. If I have just to write the tests one by one, it will be a huge problem and a huge gap, and I won't be able to give service to everyone. So what you can do is just to generate the mocks, generate the test as soon as possible, give them to the squads, give them the way to work with them, and that's a good thing. So from the Swagger tool, you can just generate those mocks, those servers. I will show you how, no why, why as well, but I will show you how. Because as I said, if you test this in advance, you will be able to face, I don't know, but campaigns like Black Black Friday in my case, or like Singles Day, or whatever Christmas campaigns in a retailer that's important, or we would be able just to overcome some major changes like COVID, okay? Like when in March 2020, we have the COVID and everyone ran to the stores, to the supermarkets, and Lidl was overwhelming with tickets everywhere. So we could have been ahead of the curve just to notice that. So what can we do with the mocks? I mean that so it's really easy to see. I hope that you have used that one as well before today. Joder, perdón. Ahora, vale. So it's really easy just to generate a mock. You can use whatever well, whatever language that you prefer, whatever technology that you prefer. We can use Python Flask, for example, that is that is comfortable, and it's really easy to see. But for example, we can use the Kotlin server, that is our application for Android is in Kotlin. We could use as well some Rust, that is really nice, Haskell or Go server that is really performance. We could use whatever we want, but whatever that we are comfortable with. And we just can have well, this Python Flask server. We follow the README, and you could see. Actually, I'm gonna open it. You can see that it's really easy just to install it and to see it. Downloads. I think it's here, for example. Yeah, Python Flask servers. I think it's like around there, somewhere of my. Well, I can just. It's in temp. Yeah, I know where it is now. As you can see, it's in open recent and temporal. So you can see that I have a Go server as well and a Python server. So you can see that we can have a Docker or Docker file just to do whatever I want, and the README that says how to install it. So whatever is the language that you prefer, whatever technology you prefer, you will have a generated README just to have it running this server with the specification that you have in your OpenAPI. So it's really cool. You will have it locally. You can so you believe me, you just have to do this like this. So the temp and Docker build. Okay, if I have it where it would used to be. Nope. I can have it here. This is a terminal. So you can have it here. So I have now my Docker just running, and I can have this server here, and I would have just the server just running in my local. So I could try my specification here, my tests. So back to how do we have this is just the mock where we are going to, this is like our environment where we are going to test the tests actually. So what is the first step that usually people have? The first step to test something, communities like just to use right now, just to import it with, well, I'm gonna change this well again, to import it in Postman. So I can have the Open API specification that in our case is this file here, that is this, I'm gonna change again the window. Open folder, open recent, this one here. So this YAML here that we had, this vector store example, for example, or the simple API YAML. This is the Open API specification. So we have here what I said, we have who has done it, we have the endpoints, this is the inventory, search inventory, the post and the gets. So these are the responses that we have. So what we do, which is the first step that we do to have this open API specification tested? We can use you can use, for example, Postman. That is a really powerful tool. So we can import the file just to have the specification, and just to have the test in a new way. So this way we can see as well how to start working with our tests, how I start working with the tests that we can have. Okay, but this is not yet a performance testing. We just have a way to test an API that we can work with it. There are a lot of talks about how to work with no quiero descartarlo. How to work with Postman in order to have some testing done. But we are focusing on performance testing. What is the first way? What is the first thing that we can do to check a bit of performance with Postman? We can, for example, really ñapa. So that is really that we are going to call that API for a number of times. That is with this 100 iterations. For example, this is a really simple way to test a bit of not concurrency, but just to test a bit like sequentially how many times we are going to call that API. So we have, for example, 100 iterations. We can just you have the code. I will share the repo afterwards. But you can see that the only thing that I'm calling is the URL actually my local host, and you can see that actually it won't work. Yes, it's working. Actually, it's working. I thought it's gonna work because I know I have it running. Usually I don't have it running before I execute. So you can see that everything here is working. All the response time are below 1 second, and actually it's calling our server. So everything is fine. Everything is going fine. You can see here the response time. You could put whatever the delay or the maximum response time do you want to as a validation criteria. You can just put how many milliseconds do you want for this test, and you could run. This is the first way to run it, but of course we can use another tool. Okay, so usually the performance engineers will use JMeter. And how do we get the test from Postman to JMeter? It's a really easy way to do it. The easiest way is just to have here in the settings, just to check to put a proxy that actually is calling the proxy that you create. So the mirror, the proxy sniffer that you create in JMeter. Okay. In JMeter, in Seal Performer, in Load Runner, you have all in all these commercial tools or non-commercial tools, you will have this feature. You can create a proxy just to sniff the traffic that it goes through it. So you just have to configure your Postman to go through that proxy. Okay, so for example, in JMeter, that is one of the easiest ones, or well, non-commercial, most used tool, performance tool in the world. You can just add a test script recorder that actually is a proxy. In local proxy, you have to start it configured like it is. Definition of endpoints. Okay, here. So you just configure it like with this port or whatever port you have available in your laptop or in your server, and you just start the proxy. So with this, once it starts, whatever I send from Postman, it will appear in the in this case in the target controller, and the controller that defined my JMeter. It's this one. It's a definition of endpoint. So this is as easy as if I send this, well, not this one, it's gonna, well, oh yeah, it's gonna send 100 requests and you will see it. I'm gonna bore myself. You can see here that it will be like 100 requests in JMeter, okay? So you can see that it's really easy to have. So I'm gonna stop it. Or well, I'm gonna delete it. The 100 will take 100, okay? So if we have, if you saw that I imported one open API specification, it just created me a collection. It was this one, the simple API. So I can just get here to the test in the Postman, to the definition in Postman. And of course I can send, and it will show, well, 4.4. It's not actually implemented, but it's shown here. So it's really easy. You just now have to work a bit around this one. For example, I can add here that, well, I don't need the Postman token. I don't need the user agent. Maybe I need another user agent that I want. I can just use an assertion, but actually the definition, you have it. You have it already, so you don't have to touch it. Okay. So you can work with it in any of the other modules that you will be working with, the workloads, and to put the number of users and this kind of stuff that we do in performance testing. But actually from Swagger, you saw that from the API open API specification, I can just move to JMeter really fast. So let's follow. You see, that's really easy. I get paid for this. Don't tell anyone. But yeah, so you saw as well that we have this Swagger. I created the server, but as well we can create, and that's more or less of a secret. Well, it's not a secret, but you can see that we create actually as well clients. And one of the clients that is here is as well a JMeter client. Okay, here, JMeter client. So Swagger editor, or well, a Smartware editor, the Swagger environment, the Swagger hub, give us as well a JMeter client. I don't recommend this one because the description is not really that good. Actually, it has a lot of parameters. It's not that clean if you do it through Postman. We can see an example. I will just open. I will open one. But you can see it's not that well. Actually, I don't know if I have it. I can download it, but I don't want to show you how it is because it's not really nope really that group. So it's gonna put like a lot of stuff that you actually don't need. Okay, so rather just stay with the one that we go through, that we create for ourselves. Okay. Well, it's here, admin API. Te visto. So this is how it creates. So the test case, this one is downloaded, the JMeter client downloaded from the Swagger editor. You can see that they add like this kind of added test case with a CSV that it's loaded. So it's not that really that efficient. So just to stay with the other one. If you are really in a hurry, you can use this one. You can just download the JMeter from the client, from the generate client JMeter, and you can use it. But actually, it's preferable to use the other one. Okay. So yeah, we are here. Asturias left. So we saw that how we change from Postman to JMeter. That's really easy. But actually, JMeter, if you saw, it's not really a cool. So it's really a cool. It's really a good tool. It's really cool. There are a lot of community behind it. There's a lot of people behind it. But actually, the code, it's awful. It's GMX. Okay, this is the code. This is like almost not human readable. So we moved from YAML that is human readable to this stuff that it's horrible. Okay. So what can we do? What can we do? We have a tool here called, well, this is something else. Basically. So we have here a tool called BlazeMeter. BlazeMeter it's a wrapper for different engines. So you can have Selenium, for example. You can have Gatling, it's written in Scala. You can have JMeter. So you have the different performance engines below, and you can have like a more human readable configuration for your testing purposes. Okay, so you have a performance test, but it's really easier to read than JMeter. So what we can do with this? We can just create a simple API in YAML well, this is a YAML of the configuration, but the test would be something like this. Okay, so you just define which is the executor, that is engine that you're going to say. So for example, I said here that you can use Zunk, that it's another engine. For the, by default, the executor is always JMeter, and you can use whatever you want. So the specification is just to put the request and well, a bit of configuration here, right? The thing is here that you can see that from the simple API YAML, I can go straight away. I can do just a simple command. Me voy a cargar esta. I'm gonna just to delete this one to see to show you how I can do it. Okay, so the command is just is under Python, so blaze meter is bset. Okay, but in this case we can say just swagger to YAML and the name of the simple API YAML, the specification, and you will see that it will be converted to this one here. So that is even laziest. It's the laziest thing that you can do. You have a command that does it for you. Of course, you can touch it. You have to touch it. Don't tell anyone. You have to work a bit with it, okay? But the specification is right away. It's just a command. So automate or die. If I have to give service to 24 squads, just imagine I need to do this, to have simple tools just to make the work faster. Of course, you can create it from scratch. That's something that you can do, of course, and you can as well work with all JMeters that you have in a way. For example, just calling your script. So you can use blaze meter for anything that you want. So if you have Selenium tools, you can call your Selenium. If you have JMeter scripts, well, JMeter tests done before through GMX, through the interface, you can call them as well. If you need just to call a locus that you have in Python written, you can call it as well. It's a wrapper. And the only thing that you have to do is just to change the test. So do you want me to check if this forward, so this simple test that I created through this command, sword to YAML, is working? It will work. So if I do visit at blaze meter Taurus simple API YAML, well, I don't know how many YAMLs I have here now, but I think it's this one. It will just open the console from blaze meter Taurus and it will start working. It will do the same. Okay, so you can see that we have, from an open API specification, from a YAML, we have a working test, and that's all. That's all I wanted to say. That creating the tests for performance testing purposes is really, really, really easy, and you can make it really fast and automate. Okay. I think that if you have any questions or anything.
Thank you.
It was a bit fast.
No, but thank you very much. Yep. Great presentation, very interesting. I would like to ask Marcos whether he sees any questions towards you.
Thank you. Thank you, Almudena, for this great presentation. I think it's super cool. This wow effect at the end, I think, is game changing, to be honest. And yes, actually, there is a question about we have in our daily basis pipelines like Jenkins pipelines and so on and so forth. So how do you see this integrating in pipelines like with Jenkins or GitLab in order to pass through all the steps, unit testing, component testing, and now plus this performance testing orientation with the proposal that you have here?
What I do usually just to have actually we have like 2 CIs. Okay, we have a daily basis or a build basis. Actually, with every commit we do a little performance test just to check the trend. It's just checking build after build. It doesn't do a dimensioning of the system. It just checks if anything is going wrong, if you have more response time, if you have more requests in one side or whatever. That's with each commit, with each build that we create, we have this CI that just gives an insight of how the performance trending is going. It's like 1 minute, 2 minutes with 10 users, nothing else. It's like really this is it. And we have like a weekend CI that performs actually in a pre-production environment in Azure. We just have all the well a little pre-productive environment just create for those weekend performance tests. Because actually it's really expensive. We have to say that it's really expensive. So each weekend, or well, actually every 2 weekends, we have 3 days of running performance testing, dimensioning performance testing. That it's like a longer performance tests. It's not only APIs, it's just the flows of the users, how the users work, and they are more I don't know how to say, but more deep. Those last 3 days from Friday to Monday morning. Those are based on these ones, of course, but of course they are more intelligent, for just to say, so they have more scenarios and concurrency and this kind of stuff. But these ones that you have seen, you can use it in each commit. 1 minute of this and you will see actually if you have a query, if you have a wrong query, if you are calling too many, I don't know, if you are opening too many handlers, whatever, this is really a huge issue in performance wise, you will see with these ones.
Cool. Thank you very much, Almudena. And again, a great presentation. Angel, no more questions by the moment. I will keep an eye just in case we have something else for Almudena. Thank you.
Perfect, Marcos. Thank you, Almudena. Now we have Hector Dobao speaking about MS SQL Server Azure Cloud Overview. So all the stage is yours.
Thank you very much, Angel. Yes. And hello, everyone. Let me remove the mask. We have far enough distance, sorry, and fresh air, fresh Asturian air coming into the window, so it's nice. Okay. Hello, everyone online. Let me share the screen and start with the presentation. The code is not catched. No, yes. Okay. Good. First of all, let me present myself on quickly basis. Well, I'm a technical telecommunications engineer. I'm working as a database administrator. I've been working in this technology, SQL Server, for more than 10 years. And of course, as everyone, we started mainly with on-premises environments, okay? What do we need to understand about on-prem environments, on-premises? You think always in the physical stuff, right? Any appliance, any data center, anything you have on the physical wall. And into that, you may have, actually, we have virtual machines and a big ecosystem of software, hardware, and everything, right? So the main aim of this presentation is just to let you know about what is MS SQL Server Azure now into the cloud, because we started with the on-prem environment, as I explained, but now we are going to the cloud world, and essentially the companies and the industry is a big trend, right? Trying to go to the cloud as fast as possible. Of course, this is, I consider that we are in a transition period, okay? So now companies are experimenting with the cloud and are explore the new options that the cloud offers, okay? So basically, this is me, yeah. Okay. Basically, starting with this, I want to introduce you with the cloud system, with a cloud system overview, okay? Then I will tell you more about the SQL, my first and my current technology in which I'm working on with. Then explain about the MS SQL Server a bit in Azure, and then finally some questions. If you have any questions, feel free to ask me. Okay. Well, so as I explained to you, MS Azure, concretely the cloud, you know, in the market, there are several cloud systems like Google, AWS of Amazon, then IBM, Oracle. But then focusing in the cloud world in general, we need to define this as an ecosystem of resources, right? So we need to think, as I introduced to you before, we need to think that the physical world has now moved to the cloud world, and everything is on the same container as an ecosystem of resources, right? So you don't need to think, well, I have a storage cabin, I have a big appliance, I have virtual machines into that, okay? We need to think everything as a service, right? So the cloud world offers to you, not only for SQL, but also for many, many products, you know, applications, full systems, Unix, Windows, whatever, to be integrated into the cloud world on a faster way, and reducing some administrative tasks, especially the repetitive tasks. Okay, you don't need to work on the physical maintenance of the storage, or I don't know, the cables. Okay, the fibers, anything. Okay, everything is on the cloud, right? This is another nice GIF. Okay. This is Microsoft official, okay, I promise you. So, as I explained to you, the big ecosystems, this big ecosystem contains tons of items that I'm going to describe now. I will concentrate in the main ones. First of all, cloud computing. Cloud computing is a really good concept. I like it because with cloud computing, we can understand several things, but the main concept, I think, is imagine the cloud as a big computing system that could process anything you want and anything you upload to the cloud. Of course, depending on what you pay and the options available. But the cloud computing is nowadays, I think, the present more than the future. So it's really nice. Okay, resilience. This term I love a lot because resilience, you can understand this resilience as the capacity of any system to overcome any failure or any major issue that it has. And it has to be necessarily joined with the reliability. Okay, reliability is something in Spanish we say fiable. Okay, in English we could think about full availability, nearly 100%. Okay, so if you sign any contract with any cloud system, perhaps, of course, they will tell you, well, this will be 99% fully available at any time, right? The reality is that they offer you one SLA of, in terms of availability of the system, more than 99%. Then the 99% could be 0.5 extra, 0.9 extra. So this is the service level you need to pay for, right? And then finally, scalability. Okay, scalability is also amazing because with this capacity that cloud offers you, you can increase your systems up in terms of resources. So before, if you need to add some RAM memory or some more disk, you need to go to the data center and insert into that the hardware, right? Now you can do it automatically with the cloud portals and increase the capacity of your system, right? Then, as I explained before, as a service concept, as a global ecosystem of resources, right? So this concept is also applicable for some applications, like I'm thinking about any ITSM system like ServiceNow, for example. They sell everything as a service, right? Or perhaps in empathy.co, right? Okay. So service models. This is related mainly with how SQL Server or other systems are migrated to the cloud, okay, then I will explain better about them. Infrastructure as a service, platform as a service, and software as a service, okay. This last one is more related with the Office 365, for example. I will explain you later better. Okay. And then I need to stop on this hybrid model, because the hybrid world defines everything what I told you before, okay? The hybrid model could be defined as a transition from on-premises environments, so physical environments, to the cloud, right? So the companies now, this is the current situation, I guess, for most of companies, they highly prefer hybrid model instead of having everything in the cloud or having everything in on-prem, okay? So it means that it's really necessary to have a transition period for this. And Azure is offering with several layers and applications like Azure ARC, for example, to administer your current environments in the physical world and also the cloud world, everything on the same interface, okay? So if the customer goes to the cloud, you need to make him aware and that everything is a very trustworthy environment, right? So you need to provide some tools and move to the customer to the cloud step by step, okay? Not suddenly. Well, as I told you, this big ecosystem of resources is across the world, distributed in several data centers, okay? In this case, now actually Microsoft is deployed and available in more than 140 countries. Then we have 54 regions worldwide. When we talk about a region, in the next slides I will explain you, we talk about several countries, right? Having a region doesn't mean that there's one data center there. No, a region normally consists on 3 different data centers in terms of for keeping the high availability and the redundancy between the systems, right? So actually it doesn't appear here, but I think because of COVID, we have actually, Microsoft is building one new data center in Madrid, okay? They expected to open it by, I think, last year or next year, I don't know. But now we will appear in the map, right? Hopefully soon. Okay, so going further in depth to this, as I explained to you, an Azure region is composed of 3 different physical data centers and locations. They are differently separated, okay? Of course, connected by fiber channels and special communications. And they are between one or two of each other. They could be located at few kilometers away, right? In some cases, more than 50, in other cases, 20 kilometers. And this will ensure you the high availability in case of any disaster. Unfortunately, we are living a war, right, in Ukraine. So imagine that any bomb destroys any data center, okay? We could have available another one and the services will not be impacted, okay? Within a region, what will we find? We can find also availability zones, okay? The availability zones, imagine that are like little ecosystems in each data center physically, okay? In each of them, you will have everything, the storage, CPU, memory, and you can locate your virtual systems there under one big item, and the key item for Azure, which is called resource group, okay? Under the resource group, you can locate all your system, applications, storage, databases, and so on, okay? So, of course, you can configure your Azure systems to be replicated across 3 zones, okay? Or just make local replications of your data, especially for the backups and databases, okay? What does Azure offers? What Azure offers is that despite of your configuration you have, okay, the configuration you have, sorry, they are replicating continuously all content by default. Okay, so it means that you can increase your availability level, but Azure have some extra layers that are replicating everything on the background, right? So it makes it more attractive. This is another diagram, okay, related with the availability zones and regions, more schematic, okay. So first of all, as I told you, we are located in one region. Then we have three different data centers, bidding them availability zones. And then in the same data center, we have last item to comment is availability set, okay. Which means that you have a local a pool of resources and you can define your resource group there, okay. Well, about the scalability, it's a nice term. As I explained to you before, about the scalability, you can talk about, or you can think about, well, when I'm running out of any resource, for example, I need more memory, more CPU, you have two options to increase it, okay? You can increase the amount of for example, amount of disk, right? You can add some resources within the machine and increase your disk until, I don't know, whatever you need, right? It has the main disadvantage that you may pay more than desired if you have a big machine, okay? Instead of having small machines that you can segregate and you can add into the same pool, then you will be able to, with software layers and so on, you can make this on the same unit, right? And then you can have the same power and the same cloud computing grouping any small systems, right? So this is the scale out model, right? So in Azure, it's offered also the scale out model, which is the more extended ones, which means that, well, if you need more disk or more memory or more CPUs, Azure on the background will add these resources step by step and individually and add everything into the same pool, okay? In terms of costs, is more efficient. This is the big contrast comparing with the on-prem environments, right? Okay. Then about the service models and also about what is as a service applicable to Azure. Well, we have, as I explained to you, several service models: infrastructure as a service, platform as a service, and software as a service. What is the main advantage respect to the on-prem environments? In the on-prem environments, we are talking about the infrastructure as a service, right? Which means that our companies has to administer everything of this, right? And you can have this replicated into Azure also. You can move all your virtual systems to Azure and can administer the same, okay? Azure administrators, of course, keep the previous layer I told to you, the previous layer of redundancies and physical systems, but you will be able to configure the operating system, the applications, the security, Active Directory, whatever, right? Then the platform as a service concept. This is a new concept. I'm highly involved on this, and my company in which I'm working on is Indra company. We are neighbors, by the way. Is working for a really important customer of the public sector, which is the EPO, European Patent Office. In this case, they decided to, well, we need to simplify the OS and storage and virtualization layer. We need to have everything more simple. Okay, we went to Azure and we saw this one, which is the current model we are using, right? The platform as a service. With platform as a service, we will start to forget about the runtime, middleware, OS, and I include, especially for SQL Server, the MS patching, for example, or the SQL product patching, and the backups. What does it mean? It means that you can be fully involved on your technology in SQL, in application. In this case, administering the SQL Server instances, okay, the databases, the maintenance plans, the data themselves, right? And then forget about some administrative tasks that you were working on until then, right? Like perform the DB backups to disk or to another backup system, and then patch the product with regular updates. You need to forget about that. Azure will do for you, right? So this is a big advantage and a new enhancement, right, with this product. And finally, about software as a service. Software as a service includes also this management layer that I talked about, right? So you don't need to administer anything about the application or the data. Microsoft will do for you. This is the big example. A good example is Office 365, right? When you use this product, you open your Excel file, your Word file, whatever you need under this suite of products, and you will use the applications directly. You don't need to take care about anything else, right? About pay only for usage, I will talk later in another slide, okay, about the pay-as-you-go model and so on, right? Then, of course, going back, scalability, the same. In any layer, you can use the scalability for increasing your resources. This is what I explained to you, right? You don't need to take care about some administrative tasks, right? Microsoft will do for you. And then you will be totally focused on this specific product, right? You are managing. Okay, quickly on this hybrid model is a transition model from on-premises to the cloud. So now the companies are going on this strategy, most of them, right? They are trusting the critical systems for their environments, but the other environments with less value or less critical, they are starting to migrate to the cloud, right? So it's easy with this diagram to understand what we had and what we have now, right? Then with proper connections and proper assistance that Azure offers, you can connect easily your physical infrastructure to Azure, and then they will provide the rest, right? And you can work with both systems easily. Of course, paying for the correct linking, like the express route or similar, right? They are like tunnels or VPNs specials to connect your data center with Azure. Okay, then about SQL Server, nice technology. Do you know SQL Server? What is, right? It's the database system from Microsoft. I've been working for more than 10 years in this technology. It's really nice, but now I'm discovering the new world. But the concept is the same, right? SQL has been the same technology since its beginning. So you need to understand this as a database management system using the Transact SQL language, okay? This is a big ecosystem of databases with tables, views, procedures, etc. This is our relational database system, as I told you, with a special order in the data and fixed structures instead of MongoDB or MariaDB or Cassandra, which are non-SQL systems, okay? And this is widely extended across the on-premises infrastructures, of course. As I told you, SQL started in on-prem environments and now is moving forward into the cloud. Okay, so what we have available into the cloud for SQL Server? We have the models I explained you before. With the infrastructure as a service, we have the virtual machine, especially with Windows, and you can use, of course, SQL Server under Unix platform too, but mainly in Windows is the most extended. You can move your virtual machine and you can think the same that you have in your physical environment. You have virtual machine with the Windows system and then with SQL into it, right? And then in platform as a service, we have two options. This is new for you now in this presentation. We have the Azure SQL database and the SQL managed instance, okay? We need to think about these different SQL management systems because the first one, the Azure database, is less complex in terms of administrator. Okay. Then the managed instance is to have the same you have in the on-prem environment, but in the cloud, forgetting about the backup and the patching, these administrative tasks, right? But the appearance is different. The Azure SQL database consists only in the database itself, and the managed instance consists also in the SQL Server engine, right? So you can touch any further options. And then, it's a little typo. This is software as a service, sorry. But SQL is not available for this kind of service level, right? So we can skip it. Then about the migration, perhaps you are wondering about the migration strategy that the companies could take. Well, SQL in Azure offers especially several options, but the main ones that is widely extended is the DMA and the DMS, okay? Before migrating anything to Azure, you are able to perform a migration assessment, which is a big scan of your product and what exactly you have currently in your physical environment. And then after this assessment, you can migrate it easily, okay, with some specific services and network mappings and so on. I will explain you later. Finally, about the Azure cost model, okay, important also, you have three pivotal items. First of all, the subscriptions, okay, which is the real payment you do under Azure. The subscriptions are with multiple options, right? Pay-as-you-go concept, I will explain you later also. Pay-as-you-go, you can understand it as a previous payment of the resources that you are not used yet, okay, but you are gonna use it, right? And then, of course, you prepayment these resources, prepay. So if you need more, you need to pay more, right? But you will have the security that you will have a pool of resources available, fully ready for your migration before you go, right? It's the main concept. And then finally, the DTUs and cores, depending on the usage of your database, if you need to consider the cost per resources used, right? The CPU, the memory, and the I/O of your database, you can go to the DTUs. If you go to the core model, it means that you will think about a bigger ecosystem, right? You will not take care about the activity. Okay, you only will have a big machine and only you can put the database there, then, right? This is another sum up, but more applicable to SQL. We have this service model in general, service models, and then applicable to SQL, the same, right? We forget about, in platform as a service, we forget about the administrative layer like this. And then in this one doesn't exist, but just the concept that, right? This management layer is eliminated from here. And this is the big model that we are using now, right? Okay. So about the pay-as-you-go concept is really nice because you need to think always about how to pay the Azure system, right? This is some abstract for you because everything is in the cloud and with a web portal, okay? You can use some APIs with PowerShell also, with Azure CLI command lines to administer, but the main door is the Azure portal, right? A web page I'm going to show you later, right? Then going to the platform as a service model, as I explained to you, if we see the Azure SQL database concept as a single database, you have several plans depending on your activity or your workload of the database. We have several plans like basic, standard, premium. Okay. The main difference, for example, if you think about basic, you can think about a sample database. Okay, with few features, no for commercial work, right? Standard will be more professional use, but for example, think about normal drives, the on-prem drives, which are hard disks. single slow disks, okay? And then Azure makes you the premium model using the solid state drives, right? This is one of the main ways like Microsoft measures the performance and define the plans, right, to purchase on them. Then about single database on Elastic Pool, you can choose a single database with pre-allocated resources or choose an Elastic Pool. Elastic Pool means that you can increase the pool of resources because, for example, when you need an extra computing, all right? Imagine that you have a single database system, okay, that you are using 8 hours per day in business hours, and then you need to process some data during the night. And you need some more extra computing to process all data, okay, with data inserts or data deletions. So you don't need to pay 24/7 resources for that. You can choose the Elastic Pool feature, and you can choose these small resources you need, extra resources, for a short period of time instead of choosing them for the whole day, right? And then about managed instance, the same like this, but with seeing the full database engine, okay? And for a DBA, it's more, from my point of view, it's more familiar because this is the same that we have in on-prem. Two kind of services, service models. General purpose and business critical. General purpose in this case means the same I commented previously, sorry. It's related with the drives, right? If you think about computing, they are using some standard disks, some standard hardware. And then if you choose business critical, it's the same than premium, right? They have a nice equipment of SSDs, right? Solid state. So the computing is much faster. Then you can have a single instance, or you can have an instance pool, which is now is still in public preview. Okay, it's not released yet. It means that you can install several instances, so several servers of SQL under the same pool of resources, right? The same pool. And then about the purchasing models, as I explained before, the DTU, database transaction units, it's a nice comment, okay? This is totally abstract for us. Microsoft has this formula. This is an algorithm that is not released. Microsoft makes an average of the usage of the CPU, the memory, the IO, etc., and calculates this number, okay? Depending on this number, you need more DTUs or less, right? So you can purchase for them or not. And then about the cores is slightly different. You cannot measure your systems by the usage. You need to measure your systems with in terms of computing, right? You have a big server of a big database that, well, has low activity, but imagine that, for example, a data warehouse, okay, a data store with huge amount of data that doesn't have much activity. You can choose the core model, right? Okay, this is a big sum up about we have about the options available on each layer, okay, in infrastructure as a service and platform, and yes, platform as a service, but applicable to more options with the serverless, yes. Well, then a quick diagram about a comparative of each system, okay? So it requires a lower administration effort or a higher administrator effort. If you see this diagram, if you go back on each line, you will see what I explained to you, right? Lower cost and lower administrator effort. Starting by the physical and go up for them. Okay. This is a diagram of Azure SQL database, okay, explaining what is the Azure database ecosystem, okay, thinking about a database as a single item with everything and with these associated tools. The managed instance is considered as a virtual cluster mounted on an extra layer in the Azure background, okay, with two separated engines, okay. This is the SQL service and this is the SQL management with the databases and the drives. So basically, this diagram describes that Azure creates a virtual machine. Then you have into that the databases, and with the Management Studio tool, you can browse those databases, okay, as you are do in on-prem environment. The database migration service, as I explained to you, you can do a previous assessment of what you have in on-prem, and then you can go to the Azure Cloud Wall using some jumps that Azure puts to you, okay, in the middle of the migration, okay. This is automatically provided by Azure. All other database systems can be migrated to the SQL from Oracle, from MySQL, from Postgres, and also we can migrate all other data from other cloud systems, right? This is a main and a big advantage here. So basically, and on quickly basis, just to comment that these migration services are so complex to configure, but once you configure your connection between your on-prem environment to the cloud, everything can be migrated easily, and really this is really automatic, okay. With some scripting, you can migrate a set of databases if you want, and from all these systems, okay, once everything is configured. And then you will get the nearly 100% product in the cloud that you have in on-prem, right? It's not exactly the same because the management layer I explained you before, but if you have, for example, OneSQL 2019 or 2022 in on-prem, you will have the same with another label, but it's the same essentially in features in Azure too, okay? About the cost models, I'm finishing this presentation just to comment about the subscriptions and pay-as-you-go. As I explained to you before, with the pay-as-you-go concept, you can pre-allocate some resources and then go to the cloud. But also you have this nice tool which can estimate for you which is your forecast in terms of costs, right? Which of each items are you using, okay? And you can estimate your costs. And if you see that, well, this is far enough, this accomplish our objectives and is compliant with your budget, okay, you can see in this graph, okay? And you can put some metrics to alert you if the budget is exceeded or is about to be exceeded, okay? Like this. And finally, for completing this presentation, I'm going faster. Angel, don't worry. We need a coffee, yeah. No. Azure ARC, okay. This is an amazing, really amazing tool which I'm working now, right? The ARC is one of the latest Azure feature released, okay. With this extra layer, you can, sorry, you can manage all your on-prem systems from, sorry, from other clouds and also from other database systems or whatever systems you have, right? This basically is a main and a single portal that you can connect to everywhere and then manage everything from the same point, right? So basically, this is being developed also with more features, but you have several other clouds or other systems, Azure offers you to manage them also from the same portal. This is really nice, okay? And finally, this is a little demo from the last product I'm working on, okay? This is a plugin of the Azure Data Studio, which is the application that has been replaced or is replacing the Management Studio. But basically in this, you can see what easy is to migrate a database to Azure, right? You can choose in this application one single extension from, you can select it from other extensions available, and you can only select your on-prem environment, choose the Azure SQL migration, okay? Migrate to Azure SQL and it's done. You can put the details and the database will be in Azure on an easy way, okay? So that's all, folks. And if you have any questions, anything else, let me know, okay?
Thank you very much, Hector. We're gonna have 5-minute break. I don't know if Marcos, you have any questions for him. In the meantime, I will ask here the people in the room to please take a break, grab a coffee, and then we'll come back in 5 minutes with the presentation from Roberto. Thank you very much. Thank you very much, Hector. Marcos, any questions from your side?
Yes, actually, there is a question. Which is the main, only one, if possible, reason to rely the databases on Azure SQL instead of deploying them into open source database like MariaDB or something like that?
Sorry, I did not understand you well. There's a lot of echo here.
Sure. So the question is, let me bring here. So the question is, which is the main reason to rely databases in the SQL, Azure SQL databases instead of deploying them in another open source solution like MariaDB or something like that?
Oh, in terms of what? So change Windows as the main platform against another platform. You mean that?
Maybe. Let's go in that way. There is no concretion on that.
Well, I will say that SQL Server is designed for another stuff, right? When SQL Server appeared, we need to think about one relational DB system, right? But then the huge amount of data that now are being exploding and processing from the companies, I think they demand another database relational system. In this case, non-relational systems, right? So I think this is the main reason why MariaDB or MongoDB especially are taking up a lot of the data market, right? Because the current data analytics and this kind of layer, okay, also the IEAs, require such amount of processing and data that the relational system cannot give to them. Sorry? Irrelational. I thought. Oh, sorry. I'm sorry. Yeah, I'm not an expert of Maria. Perhaps in terms of costs is the main reason, right? So SQL Server, it's not an expensive product comparing with Oracle, but MariaDB for sure is cheaper. I cannot tell you any other reason. Perhaps the management layer is easier than SQL. It's lets more interoperability between the systems. I don't know.
Cool. Thank you very much, Hector, and thank you for your great presentation.
Welcome. Thank you.
Do you hear me?
So I have one question, because in my company we are switching now from AWS to Azure. We are using Aurora, Aurora, which is on steroids, MySQL, for saying that AWS is putting there, and now we are moving to SQL Server. The guys from Microsoft are helping us to decide which one to choose. So manage SQL or, and there were some limitations about the size of the database. There was something around 5 terabytes can be. So apart from which one you want to choose, there are also limitations on the size of your expectations of growth. It's something around that also. Okay.
Yeah, depending on the SQL edition you choose. Okay.
Okay.
I think a standard edition supports up to 2 terabytes, I guess.
Okay.
But then the other one, for sure, more than 5 terabytes.
Okay.
The thing is that in the cloud, we need to think about the cloud system capacity. In this case, I think the premium Azure storage with the highest model available for SQL could offer you, I don't know, 8 terabytes, I guess, 10 terabytes. But in this case, well, the thing is, SQL has its own limitations, you know.
Yeah.
So if you need a database system of 10 terabytes, you don't need to go to SQL, or just to split the database into different ones and use the resource pools available.
We we already have partitioning and archiving, etc. So that's the way to go. But I
That's
think they
it.
were looking at one option, and then because of the limit of 5, moving to the next. But it's good to know that there are limitations and you have models.
Yes, of course. In terms of costs, perhaps it is worth trying to go to a MariaDB system instead of SQL because the capacity. Okay, that's fine. Or the development effort required for splitting the database or whatever you need, right?
Cool. Thanks.
Welcome.
Thank you very much, Hector. 5 minutes break. We'll try to keep it short, and then Roberto will continue with his presentation.
Cool, thank you.
All right, Marcos. I think we are ready here to start. If you can hear me. I think you're muted, Marcos. I think we are ready, but Marcos is not with us. Let's check. I think Marcos is having an issue right now that he's not hearing me. I don't know if anybody online is. Apologies for that. Bart, do you hear me? Yeah, okay. I think then it's. I think Marcos has a problem with the sound. All right. Anyway, I think we can start here. Roberto, if you want. Okay. So let's give him a couple of seconds. All right. Stage is yours. Whenever you want to start. Thanks.
Cool. Thank you. Does this work? Okay, so thanks for attending. I'm Robert, and I work as a. Oh, sorry. Thanks for attending. I'm Robert. I work as a platform engineer at Empathy. Well, David already explained what Empathy does, but if you're not familiar with us, we are a software company that develops search and relevancy solutions for mainly other e-commerce business. And as part of the platform team at Empathy, our goal is to enable the application teams and the product teams, which are the ones that actually fulfill the business needs and the goals, enable them by providing them with an internal platform to support all the different phases during the software lifecycle development, the software development lifecycle, sorry. Allowing them to iterate fast, with confidence, and try to be self-sufficient, and following DevOps practices, and also trying to solve certain common problems that we know that multiple application teams are going to face. So that way they don't have to reinvent the wheels by themselves. And today we're going to talk about how to improve the way that people work using Terraform by adding features like automation, cost visibility, and the ability to enforce certain policies. So a bit of an intro. If you don't know about Terraform, I guess some of you are already familiar with, but it's an infrastructure as code tool that for any major cloud provider and even for other services lets you define the cloud resources that you want in a declarative way as code, as text files. There are other similar tools like CloudFormation, which is AWS own tool, or which lets you write infrastructure as code using a familiar language like JavaScript or Python instead of instead of Terraform that uses a custom language. But today I'm going to talk about Terraform, so I'm sorry, no judgment if you use any of those other tools. But we are going to focus on Terraform, which is what we use mainly at Empathy. So instead of going through the cloud provider, the interface, you codify all the resources that you want as text files in this way, which in turn provides several benefits, like you can store those text files in a version control system in order for keeping history of the changes. You are more efficient when making changes because, for example, if you have to edit several resources for adding tags to them, you can do it in a simple manner via code than having to go one by one to all the resources in a web console. or web interface. You achieve reproducible infrastructure because you can recreate the infra from the code. You can use the same code to create multiple similar environments. So for creating replicas of your production environment for a staging environment and things like that. You achieve some kind of disaster recovery because if someone gets deleted, something gets deleted from the cloud by accident, you have the way of recreating that resource from the source of truth, which is the code. So for stateless resources, you have a way of recovering them. If they are stateful, like a database of a data volume, then you are out of luck for that. You need to have another disaster recovery setup. And also it achieves self-documenting infrastructure because instead of navigating the console and see how the resources or the resources that a project has, you can see it in an easy or easily identify the resources that belong to a project and the relations between them in the code files. So before we get into the cool stuff, I want to talk about what I believe is the evolution of the Terraform usage in the organizations or in a team. So you usually start here, right? Everyone has to start somewhere. So you start in the cloud console, in this case the AWS console, and you start clicking around and launching a virtual machine or launching a database instance or an S3 bucket. So you are beginning your cloud journey, you are doing things manually in the console. This is what we like to call ClickOps, which is good for learning the ropes and seeing how everything fits together, the different services, which features and options they provide. But it's not very agile because like it's slow. You need to create resources one by one, and everything is done through clicks in an interface, and it's also prone to error, right? So you start exploring options, and you discover the infrastructure as tool codes. Infrastructure as code tools. So you start writing your infrastructure as code. And since you're probably a small team, you run the tool locally, you run the plan and the apply. So you create the resources from your local laptop. This has some downside, but it feels like magic. You are defining resources as code, creating them, like whole lot of them, dozens of resources from some code files. You have codified the infrastructure and you feel like a wizard creating and destroying and modifying your infra. But then as the team grows, this becomes more difficult to handle, and you need to start synchronizing your changes between colleagues in order to not step up on someone else's work and prevent conflicts or getting configuration drift between people working on the same thing. Because maybe someone has edited something manually in the console, so there are some issues. But the benefits of this is fast, because there's nothing that you need to do apart from writing code. And it's simple to implement because you don't need any extra tool apart from Terraform. You run it locally and create your infrastructure. But as I said, it has some problems, like the state inconsistent state between the colleagues and the configuration drift between the actual state or the live state. There are also risks because someone might introduce unwanted changes or delete something because maybe the changes are not peer reviewed if they are done locally. There's also no audit trail of changes unless you dive into the cloud provider audit logs. So it has certain problems. So you start thinking, okay, maybe we should do this in CI. Maybe we should run this Terraform plan and applies in a CI system, centralized, in order to automate them. So you start exploring options. And the usual options that people choose are, okay, we integrate this into our existing CI/CD pipelines. So if we're using Jenkins or GitLab, we might add some steps to run the Terraform workflow. This tends to have some issues because of the way that Terraform works. because even if a plan succeeds, it doesn't mean that the apply is going to succeed, because the API of the cloud provider might reject the resource that you are creating if it doesn't, like if the name is too long, or if it already exists something with the same name. So it has some issues if you try to fit this workflow in a usual, let's say, development workflow where you merge to main and that gets applied. But if the apply fails, you need to fix that in a new branch and create a new pull request. So it gets messy. There's also Terraform Cloud, which is the HashiCorp's or Terraform own cloud service where automate the executions of Terraform. And there's also an open source tool called Atlantis, which you have to self-host. It doesn't have any SaaS service, but it's the one that we are going to focus today because it is the one that we have implemented at Empathy. Atlantis, as its description says, is a Terraform pull request automation, and what it allows is to integrate a GitOps workflow for using Terraform. It works with GitHub, Bitbucket, Azure DevOps, and GitLab, so any major version control system, sorry. So basically, it executes the Terraform plan and applies in the Atlantis server, and it gives you a feedback on the pull request. So instead of people running the Terraform commands locally, you force them to use Atlantis. So that way you have every change audited and versioned in the version control system, and you can also enforce things like required approvals or minimum approvals and those things. So some screenshots of Atlantis. In this case, I'm creating a random resource. So I open a pull request with this new resource, and then Atlantis executes the plan, shows me the feedback, the output of this plan. Okay, you want to create this, and also some commands that I can run in the pull request via comments. So I can tell Atlantis, okay, apply this change that I want to do. But then it says that the apply failed because the pull request must be approved by at least one person other than the author before running apply. So we have at least one way to check for an approval. It's a lightweight approval process. So somebody from my team approves the changes. I run the Atlantis apply, the creation succeeds, and automatically the pull request gets merged by Atlantis if everything goes right. So now the main branch of the repository has the code up to date with the actual live infrastructure. So that's the Atlantis workflow, more or less. So the benefits of integrating this kind of GitOps workflow using Atlantis, it's automated, so everything is executed automatically with Atlantis. The changes can be audited, and there are accountable people, so you know who did what and when, because the person that suggested the changes can create the pull request, and the approvers that actually approve the pull request. You also have an approval process, but it's a lightweight approval process because we don't like those kind of change management boards and those things that tend to get in the way of getting work done, that are more like bureaucratic processes. So you have like the pull request approval processes, which is something lightweight. And it also increases collaboration because anyone that has access to the repository, but that doesn't necessarily have Terraform installed or even Git, because they can just use GitHub to propose some small changes. So everyone that has permissions to see the repository and create a pull request can suggest a change that they want to do. And then it's up to the reviewers and the owners of the repository to approve those changes and apply the changes. There are some problems still with this workflow. As you grow as a company or team, there can be like some bottlenecks because you start having lots of code reviews that you need to check in a daily basis. And also there is common to create locks between people working on the same project, because Atlantis, when it runs the plan, it locks the workspace, so it can be modified by any other pull request. So that way you stop or you avoid the problem of people trying to edit the same resources. So this is amazing. Like this workflow, if you get to this point, I think you are in a good position. You have automation, you have auditability, you have accountability. So it's an awesome workflow, but you start diving in and you want more. Like you open the doors of automation, but you want to add more kind of things to this. So for example, you start looking into adding some kind of policy checking into the changes that are performed. So here the most common option. So for policy checking for testing that the changes might follow some naming conventions, or that they have certain tags included in them, or if you have only whitelisted a certain amount of resources that people can use. So for this kind of checks, the most common tool is called ConfTest, that lets you write policies using Open Policy Agent language, and it works against several types of files like YAMLs and JSON. So you can use it with Kubernetes manifest, Docker files, or Terraform plans, which is our case. So, for example, this is an example policy that checks if the resources that we are creating have some required tags that we want on them. So if you run this, so for example, here I will be creating a bucket, but I only added the tags environment and business unit. So if I run the ConfTest tool against this plan, it tells me that the resource AWS3 bucket is missing the required tags, owner and workload. So Atlantis has an integration with ConfTest, so you can also run this in an automated way in, let's say, this CI/CD or GitOps workflow. So this is an example of Atlantis running the policy checks and outputting, giving us the feedback of your resources are missing some tags also. And then you can either fix that, or someone can override the policy checking if it's in a list of approvers. It can run a command, Atlantis approve policies, and override the policy check, so the Terraform apply can be executed. So this is a new feature that you can integrate in your Terraform workflow if you want to enforce some kind of policies. But then you want more. You need more things into this workflow. So what about costs? There's a kind of recent tool, I believe, which is called InfraCost, and the main problem that it solves is it gives you a cost breakdown of the resources that you are going to create in the cloud, but before you create them. So you can run InfraCost alongside a Terraform plan, and it's going to show you a summary of the of the cost that you're going to incur if you create those resources. So with this, you achieve some cost visibility and awareness for the people that are creating the cloud resources. And you can do this kind of experiments or what if analysis of calculating the costs of the infrastructure before making or creating or modifying the actual infrastructure. So if you are using some type of instance and you want to upscale it, you can detect the cost increase that's going to make. So Infracost has several ways of showing you a cost analysis or a cost feedback. So there's this full cost breakdown that shows all the cost of all the resources that the Terraform project has. So in this case, an AWS instance and a Lambda function. And also it has this diff costs that shows you on a change that you are performing the cost difference, the cost increase or decrease that's going to cause. So in this case, I believe the instance is removing the provision IOPS on the storage. So, but we are adding a Lambda function. So the costs are increasing 70%. Yeah, 70%. But what happens with usage-based resources? Because in the cloud, there are some resources that have a fixed cost. So an instance doesn't matter if I use it or not. I'm going to pay as long as it's running. But there are things like S3 buckets or Lambda functions. If you have seen this example, so how those type of resources are built by usage. So you can create it, but as long as you don't use the Lambda function and it doesn't run, or as long as you don't put anything in the S3 bucket, you are not going to get billed. But how does Infracost know about the number of requests or the amount of storage that I'm using? It has no way of knowing that. So for this type of resources, what they do is it lets you create an Infracost usage YAML where you specify an estimate of the monthly usage that those kind of resources are going to have. And then it shows you the total or the monthly cost that based on that usage, you are going to have to pay. And it also shows you the different cost or billing model that the resource has, which is more useful than navigating the AWS or the cloud providers billing pages, which are very confusing actually. I believe they are also experimenting with retrieving the usage of the resources directly from the cloud APIs. So instead of estimating the usage, they can retrieve the actual usage based on a previous month or something like that. But I think that's still like in beta or as an experiment. So you can also integrate Infracost with Atlantis. They have a pretty good documentation of how integrating Infracost in different CI systems. But for this, we are going to jump to a demo instead of showing it via slides. Oh, don't worry. Thank you. Thank you. I have here a bare bones Terraform project. I don't know how we are on time. I was planning on doing it, doing this with several phases, but I think I'm going to rush a bit. So in this case, I'm creating an S3 bucket called Atlantis demo and a EC2 instance. But in this case, let's say I made a typo, and instead of using a 2x large instance, I fat finger a 12x large instance. So I commit this, I add this, commit. Okay, let me, because I think I don't have the. Oh, thank you. I think it's going to ask me for. Oh, okay. Don't know why the CLI didn't work. So I push this to the repo. And I can create a pull request where we can see that I added the S3 bucket Atlantis demo and the AWS instance. So Atlantis is running the plan. Let's wait 1 minute or so. Okay, that was fast. And it shows me the output plan. So it's going to create an instance with all the parameters. And the S3 bucket. Okay, so the policy failed. The policy checking fails because I'm missing some tags. So I can fix this by adding the owner tag here in the default tags. 1 second. Thank you. Okay, thank you. That's it. I push the change, so Atlantis is going to run a new plan. There it is. So this time there are no failures in the policy checking. And I have the monthly cost breakdown. So I can see that I'm going to spend almost $2,000 a month by creating this type of instance. So someone from my team or even me can see this, and this doesn't look good. So you can review the pull request and okay, I made a typo here, or someone can suggest this should be changed to a 2x large, and maybe someone from my team also suggests why not use a smaller volume, because we are going to use this instance for whatever purpose. We don't need 1 terabyte of disk. So someone might do these suggestions in the pull request and create. Well, I can commit them directly from here. So since it's a new commit, Atlantis is going to run a new plan. You can set policies against the cost, but I'm not sure about alerts, like direct alerts. That's maybe something that you have to. Yeah, that's it. Yeah, you can set that you can create a policy check against the costs. Yeah, so for example, costs are increasing more than 1,000%, or cost is increasing over $500, something like that. So the new plan runs, and now the cost is around $300, something more achievable or manageable. So I can run Atlantis apply. this is gonna fail because I don't have any approval actually. And we have set up the Atlantis installation to require at least one approval other than the author. So if someone from my team can approve the pull request, that would be good. Okay, let me refresh. Thank you. I swear I had I've added the code owners, so you were actually notified. Okay, so now we have an approve. So a new Atlantis apply. Should oh no, actually it's going to fail because I added another thing to show that any other kind of workflow, it's more difficult to handle these cases because now it's going to fail because the S3 bucket name that I chose is not unique. Like a bucket called, what was it? Demo. Yeah, the bucket name is not available because it's like a common name. In this case, Atlantis demo. So a bucket called Atlantis demo already exists somewhere in AWS. Bucket names need to be unique among every user of AWS. So 1 second. So yeah, I add a random ID to the bucket. So in this case, it should go through or fail. Oh, anyway, that's not the right commit message, but what's failing? Yeah, let me. Oh yeah, I did the changes manually in the. Okay, I think I finished faster. Oh, using Git Kraken. Sorry for the CLI users. So well, this is going to run another plan, and hopefully this is going to be applied successfully. And with that, I guess we finish the presentation. If you have any questions, we can answer them while we do this.
Marcos, any questions?
Yes, first of all, thank you very much, David, for this great presentation and the great demo. I have a question coming from Twitter because, as you know, guys, we are broadcasting in Twitter and Twitch as well. So the question is, okay, this Terraform for infrastructure, like building Amazon Web Services instances or S3 buckets, that's okay, and that's one of the main cases of the Terraform. But what about deploying microservices, deploying applications within the system? Is that possible with Terraform? And if yes, what would be the approach?
It is possible depending on how you decide to deploy them. So for example, Terraform actually has a Kubernetes provider. So you can have your YAML resources and apply them on the Kubernetes cluster using Terraform, although it's probably not the recommended approach that I will choose. And instead, for things like continuous deployment of application and things like that, I will look into other tools, like, for example, if you're using Kubernetes, Argo CD, or if you're using EC2 instances, I probably things like Ansible for doing changes to the actual to deploying changes to the actual instances that are already running. But you can use Terraform if you are stubborn enough to use it. But it's probably not the best tool for that kind of job. So we can see that the apply succeeded and the pull request was merged automatically.
Cool.
So
thank you very much, Roberto. And there is another question from online broadcasting. There is the existence of Terraform and Ansible. Which technology is suitable for which cases, which use cases. So we see that Terraform for infrastructure. Do you see any other use case for Terraform or for Ansible, and what could be the difference between both?
Yeah. So Terraform fits better for deploying the actual cloud resources, those that you will do in the AWS console or interacting with the API of a cloud provider. As I said, you can use Terraform to actually manage the content of the servers using some kind of remote execution and SSH connection. It has some resources to manage that, but I wouldn't recommend it. And then you can use Ansible to interact with the resources, like the instances that are already deployed. Or there's another approach that people use of deploying immutable infrastructure, where you, instead of making changes to the actual instances that are deployed, if you need to make some change, you redeploy the whole fleet of instances because they are configured in a way that they are able to, at the startup, run all the automation that they need to configure themselves and join a cluster or upgrade or whatever. So there are those approaches of immutable infrastructure where you just deploy once deploy every time you need to make a change and replace the whole fleet of servers. Or mutable infrastructure where you deploy with Terraform, for example, and then you interact with the servers using things like Ansible.
Cool.
I hope that answers the question a bit.
Yeah, sure. Thank you very much, Roberto. Nothing else from online, Angel?
Thank you very much. Thank you very much, Roberto.
Yeah.
Great presentation.
Quick finish. As David said before, we are hiring. So if this sounds cool to you, you are into this, we have open positions and also for other roles in the company. And yeah, here we have some of the resources that you can check if you want to integrate this kind of workflow, no matter where you are in the Terraform stages. I hope you have learned something that you can use in your work or in your hobbies using this.
Thank you very much, Roberto. I'm pretty sure a lot of people apply. This is very interesting. Personally, I'll reach out about infra cost throughout the next week because it's pretty interesting for what I'm doing at the moment. So I'll do so.
The people at InfraCost are very friendly. Actually, I have emailed with one of the founders because he was also interested on feedback on using the tool and how to develop it and add new features and things. So I hope and the docs are really good. So they are really active also evolving the tools.
Interesting. Thank you very much. Without further ado, let's move on to the next speaker who is online. I don't know if you are ready.
Yep, I am.
Yep.
All right.
The stage is yours whenever you're ready. Thank you.
Thank you. Can't take over the screen yet. Yes. Hi, everybody can see my screen? Yes. All right. Excellent. So, hi, everybody. My name is Bart Veenstra. I'm the Director of Technology Prototyping at Backbase. And today I'm going to talk about RUM, which stands for Real User Monitoring. First, what do we do at Backbase? At Backbase, we create an engagement banking platform. My good friend Andres is also working there for many years already. I run a department that is responsible for the technology prototyping team, which basically means that we are doing the preliminary research before it even goes into R&D. It's making sure that we going to work on ideas that are feasible and doable before we are going to involve a large organization on top of it. I work basically in the CTO office, and he asked me a question: how do we track the real uses of our applications? At Backbase, we create an online banking platform which is used by many banks worldwide. But how do we track the application performance? How do we know how many users are online, how many transactions per second, what are the average response time of the requests coming from our apps, from our online banking apps? So basically, how this is only for internal usage, and it's only for our Backbase as a service customers. As of a few years, we are now also completely running the entire infrastructure for our customers, for running the online banking channels, both the apps and all the services. So we also scoped this question to only the customers that are running on our shared hosting. So I came up with Backbase RUM, and RUM stands for Real User Monitoring. The Real User Monitoring tracks the 4 key elements of an application that runs in a mobile phone or on a web page. It tracks the performance, and for the performance, we track the say that the loading of the web pages, how long it takes to load a mobile application screen, the response times of AJAX requests, but also the execution times of your JavaScript. Sometimes these can be hugely inefficient, and it's nice to really start measuring that as well. We would also like to know what kind of errors are coming up when our customers are using the mobile apps. It's going to be strange if there are going to be requests falling out or they cannot make a transfer. So with Real User Monitoring, you can also start monitoring say all the front-end errors that happen during the usage of an online channel. And on top of that, we also want to know some of the analytics of the groups of people that are using your application. We want to know a bit about the geography, what kind of device they're using, operating system, and we would like to also track the individual user journeys. In Backbase, we have a product called Digital Sales, and it allows us to have an onboarding flow. For instance, if I want to open a new bank account, I need to go through 5 steps. I need to present my passport. I need to do an online KYC system, identity checks. All those steps are basically written in a flow. And how can we track the drop-off rates of these steps? That can help us with also identifying steps that do not work well in our flow. And of course, because we can track the real users, we can also leverage that data to support teams that can troubleshoot issues such as why my page is loading for a long time. So that's basically real user monitoring in a nutshell. Many of our customers, they also want to apply Google Analytics, and they also want to apply or Adobe Omniture. But what's now the real difference between analytics and real user monitoring? So both track the user's locations, devices, operating systems, page views, and performance metrics. So you can get all those metrics in both tools. But where analytics is focusing heavy on the user engagement, the real user monitoring focuses heavy on performance. The performance of the web application and the performance of your mobile applications. How long does it load? Which actions take too long? Whereas in the analytical area, you focus more on the engagement. Where is this customer coming from? What kind of search terms did they use? Is it connected with any of the marketing campaigns we are running? So those all stay in analytical domain. Also, with analytics, you always have a snapshot of your data. For Google Analytics, for instance, if you have a high traffic website, it will only tell you about 30% of all the requests coming in, and it will extrapolate the results for you. Whereas real user monitoring allows you to track every user, every request that your application is making. Also, when you are using Google Analytics, the data is often used by the provider offering you the service. It's often offered as free, and it's also a benefit for Google, for instance, to use those data as well to build a better audience. Whereas when you use real user monitoring, the data is going to be private for your application. We are in online banking, so I feel a lot safer knowing that my data is stored on the bank servers, or at least in companies that are contracted by the bank, than Google, for instance. And if you look at the and because we use internal applications, we can also track and internal data stores. We can also use real use monitoring for intranet applications. For instance, we have certain applications that are only meant for employees within a financial organization. So you can also track the real user monitoring of those. Those applications are usually behind corporate firewalls that do not like if their data gets sent to Google. So again, this is a real good case of using the real use monitoring instead of Google Analytics. But also the audience is different. In our case, in my scope of my research, I did not really want to involve our marketing teams because they got their own tool sets. I want to focus on the business owners within Backbase. I want to enable our business owners to determine business impact and to get a better ROI over their applications that they deliver. We are more and more standardizing our applications that we deliver to our customers. And it helps us if we get a good overview on how these applications are rolled out across our different customers worldwide. So luckily, the real use monitoring is a term that's used for quite a while already. Datadog is one of the providers that offers real use monitoring. It offers browser monitoring. It offers clients that can be embedded into Android applications, into iOS applications. It allows you to replay a session. So if a customer performs a certain set of actions, you can actually replay those actions from scratch. And it comes with many out-of-the-box dashboards that provide instant value for the performance engineers. And it, of course, has integration with logs, application performance management, and other profilers. We also do error tracking. We have our monitors. One of the biggest advantages of using Datadog is that our customers running Backbase as a service are already using Datadog. So for me, choosing Datadog is also make sure that I don't have to ask my customers, and these are banks, to go into lengthy processes into provisioning new pieces of software because I wanted to track users, the real user monitoring. So it's a big advantage to use an existing platform already there. We just have to make sure that our customers start embedding the RIM client into their application. Of course, that's a challenge on its own, but I'll go into that a bit later. These are some of the dashboards that come out of the box. This is an overview of the current user sessions. We have, you can see the number of sessions over the last couple of hours. You can see when we have peaks, and you can also see what are the top 15 pages. You can see how long the sessions are lasting, what the loading times are, how many time is spent on the page. All this information is all tracked inside the Datadog platform. We can have also some user demographics where we can have the number of sessions per country, which is top 10 countries, and all the stuff. We also have we can also have a very detailed output of a loading page of all the things that are happening when you load a page. For instance, it will break down all the different steps that is needed to render a page. It will calculate how many times the page itself is redrawn, how much it takes to get the passwords, not the passwords, to get the different AJAX requests. But because it's integrated also within a complete application performance management environment within Datadog, you can even extrapolate, you can even aggregate calls coming from the front end all the way to the backend services. That's also a possibility, but that is out of scope for this research project. This is the funnels are important for us for the say our standard onboarding flows. If we have a funnel that basically lists, okay, I want to go from my page 1, 2, and 3. I want to know what the drop-off rates is between those steps, so I can also take actions when one of those when I see that there's a huge amount of people dropping off of the flow. While because of an error or something that's not very clear on that page, I can also take action. So having the ability to create these funnels is also pretty nice of the Run platform within Datadog. Now, of course, there's a lot of stuff that's done for you already, and it's not a very cheap solution, even though it says, hey, you can have 1,000 sessions and it only costs you 45 cents. If you have a bank and you have 1 million customers that are engaged twice a day, you will have 62 million sessions per month. And if we're going to track 100% of those requests, we're going to pay a Datadog 27K a month just to collect all this data. Whereas that might not even be necessary because you want to take a snapshot of this information anyway. But luckily, we can control these costs by setting a sampling rate. We would, our advice to our customers is let's put it on 1% if you have more than 1 million customers. And if you have a lower customer, say if you are more of an investment bank with a lower rate of with a lower amount of customers, we can increase the tracking considerably. So we can also control the cost a bit. So I told you about RUM, but how are we going to implement the real use monitoring in our applications? For that, we have a little RUM client, and at Backbase, we have several out-of-the-box applications for online banking environments, and these will eventually be delivered with the RUM client installed, pre-installed, and configured to go to the Datadog instance of the bank. Here we have our engagement banking platform running on AWS or on Azure, and they will connect to our fintech partners and our core banking systems. But they are also monitored by Datadog. So all this infrastructure is already in place. The only change that we need to do for our customers is to include the RUM library. So once we have included the RUM library into our customers and set a sampling rate of 1% by default, we can also instruct our customers to have them add additional analytical tools. Many of our customers run their own analytical tools as well. It could be Google Analytics, or I've read some questions this week how to integrate with the Facebook SDK. Now, I don't feel very comfortable if I have a Facebook SDK and an online banking application. But if you have an onboarding application, then it might make sense to also include some Facebook analytics in there. Those integrations should always be done on top of the RUM client, because the RUM client also helps Backbase monitor the health of our front-end applications. And with those, as soon as we have installed those RUM clients into our applications, we have several out-of-the-box dashboards that we can use. We have a performance overview dashboard. Now, I would, because we're a little strapped for time, I would just go to Datadog and look at those dashboards. They're pretty good. They have pretty good defaults as well. We have dashboards that show you the resources. This is particularly helpful if you want to figure out what the loading times is between first-party resources and third-party resources. Third-party resources are often loaded from a CDN, and third-party resources are packaged inside the app itself. So that's basically the difference between first-party and third-party. But to have a good overview on what the average loading times is of these third-party applications will help you increase the performance of your applications as well. And often, it could also provide you with a very easy fix by, hey, I see this request is going to take always very long. Maybe I should package it, make it a first-party resource, and you will have a better performing application. But you need to measure it first, right? And this is great for finding out these bottlenecks. And of course, we want to track the errors. We want to know when microservice is not returning the right response, when it's returning a 500 errors or 400 errors. So we also can act on top of it. We can connect a page or two to it to have a support engineer to take a look at why these requests are failing. So how does that tie into the Backbase data lake? In Backbase, we are in the process of creating our own data lake where we want to get all the RAM data together from all our BAS customers. With this data lake, I want to answer questions that we have in Backbase. For instance, as a chief product officer, I would like to know the usage of our journeys aggregated from all our customers to gain knowledge on which are the popular ones and which are not. Could be that we are putting a lot of focus in a journey that is not used at all, and that a journey that we thought might not be that important is used by millions of customers around the world. So this will allow, with the data lake, we are trying to answer the questions on how popular our journeys actually are. But for a performance engineer, they would like to know the response time of the different Backbase services, so they can focus more on the response time of the services that they find too slow. For us as sales, we would like to know what are how many people are now logged in, so we can also tell it to other customers. So there's a lot of people that actually want to know all of this information. And how do we get this stuff out of Datadog? So each Datadog is connected to each customer's installation. Each customer's of Backbase has its own dedicated cloud, either on AWS or on Azure, and its own Datadog instance. So in the Backbase data lake is responsible of gathering all the data that we store in our different Datadog installations and put them into the Backbase data lake. I call it the run barrel. And then from the run barrel, we can then connect Microsoft Business Intelligence, so we can create reports for our sales, product, QA, and legal departments. Now, having those reports in there, it will help our product teams to make better decisions and to become more data-driven, to know where to focus more into. QA will know what the error rates are on different services. So all these different teams will try to can basically create their own reports based on all the data that we gather from the different Datadog instances. And once we have all those instances, we can put them, as we have all those reports, we can put them into the Backbase aggregated reports. And that's where the run bar comes from. We have a real user monitoring for the Backbase aggregated reports. Of course, collecting data, anonymized data is not without our customers' consent. So our customers have to make sure that we are allowed to read their data. And basically, this is the plan of my current research: how to enable, how to create a run monitor, how to set up dashboards in Datadog, how to extract these dashboards in Datadog, and how to create reports in Power BI. And basically, I'm going to show that now, how I did all of that. Here I said that we're going to use Azure Data Factories to schedule this call into Datadog, but unfortunately, Datadog is extremely strict about their rate limits, and the Azure Data Factory does not respect rate limits. They do respect rate limits if you have a paging request within the same resource, but I have many concurrent processes running, and I simply could not get it to work, so I ended up creating something in Java. So let's look at all the moving parts of the run bar. So first we have Datadog. Of course, we have Datadog. Datadog is a monitoring application that helps you to monitor, for instance, the infrastructure. This is an environment that runs a Kubernetes cluster on AWS in 2 availability hosts, and you can see I've got 6 hosts running our applications. I have a bunch of containers running. Basically, I have got the entire Backbase installation running. I've got all my different services running. This is our showcase environment. This is an environment that our sales organization uses around the world to show our applications running with like a real data to our customers. And this is also in production. So this is, I can actually see data coming from multiple parts in the world into this application. And you can see that we have all our pods running. Basically, it's all running fine. I'm interested in the RUM applications. Each application, each channel will have its own RUM. It will have its own RUM application. Let me put it on the past month. And you can see that we have several applications. So we have a retail iOS application. And this is an iOS application that is basically a retail banking demo application. And you can see like all the different metrics from it. Like here we have some slow renders based on the version of the application itself. So you can even track the different applications. So you can see that, hey, this is a later version, but it has a slower render than the previous version. What is happening? So these are all things you can get out of the these data as well. You can see how many errors you're having. Here you can see that the network errors. So we got a 500 on this particular view name, and you can then drill down into where is this error coming from. And in this dashboard, we also have the different performance numbers as well. So we can have a look at the number of views. We can have a look at the loading times, which applications are used the most. And all this data is collected from the iOS application. And it's just an out-of-the-box installation if you're an iOS developer, you would just insert this code snippet, and you will be enabled, and it will include everything for the real use monitoring within your application. So that's great, because it allows it allows you to really integrate quickly and get all this valuable information to your engineers. So we also have a showcase business web application monitoring. This is an Angular application where we can see where all our people are coming from. Basically, we have a bunch of information stored inside Datadog. Now, if I want to aggregate this, I need to be able to pull this information outside of the Datadog instance and into my data lake. And I need to be also able to configure what data I want to pull out of the Datadog instance. And for that, I basically create dashboards inside Datadog, where I have a dashboard called BDL. And this dashboard, I can add widgets, I can create my own reports, and I can add widgets, and I can query my Datadog instances with information I want to have in my aggregated report. By asking all of these questions inside Datadog, luckily Datadog has an API. So I can use the API of Datadog to get the dashboard definition and then get all the widgets that are configured in Datadog. And then I can fire all those queries to Datadog itself. I can get the dashboard definition, and then with the logs aggregate API call, I can then query Datadog for all these things. And to do that, I created a little application. It's called the Datadog Walker. And it's a very simple application that basically checks the few environment variables, like the date range you want to track, what dashboard ID you want to have. And it will basically go through the dashboard definitions, get all the widgets, and for each widget, execute all those queries. And store the results in it's old school, but a CSV file. And the CSV files are great because it allows us to make information really accessible for our business intelligence community. Here you see the output of the Datadog Walker. It's a CSV file per day. You can see that, okay, it's running on the showcase Datadog instance from a particular date. And I see that I have a widget title that basically has 3 sessions, and I can see that, okay, I've got a visitor from India, Japan, and the Netherlands, 4 views from Netherlands, 2 from Japan, and 1 from India. And then I have some other values like desktop, mobile, and Chrome values. So this application runs every day for each of our BaaS customers. You just configure it with an API and an API key with credentials to Datadog, and it will just do its thing. And it will collect all the information and upload it into the Azure Data Lake. I'm using the Azure Data Lake Gen 2, where I upload all the files into the Backbase aggregated reports directory. And here you see that this is basically all the statistics of the last of this month, basically. So, and then basically my whole aggregation work is done. And now I can fire up Power BI to create reports of this data that I aggregated from all the different Datadog instances. And it's a Windows application. I'm using a Mac, so installed Parallels. But basically, it allows me to create the same dashboards, but from all the different Datadog instances that we have. So we have an aggregated view of all our data from all of our customers as soon as they enable the RUM client, of course. We can count device types. We can figure out the device statistics, so we can see how many times mobile iOS 15.3.1 is used. We have our count by geo country. So these titles are a bit shitty, but I'll fix it later. But you can see that these sessions per country, if I put them on the last month, you can see that these numbers correspond with the numbers I have here as well. So this allows me to get a good overview for the entire Backbase, what our applications, how our applications are performing, basically. We can also have a real-time shift in this data as well, so we can make a selection. So I want to have only data from this date. You can see that we have our geo country map automatically updated. I know it's a Cloud Native conference. I'm showing a desktop application, but I think it's pretty cool that how quickly I can create these reports, right? It also allows us to create funnels. And a funnel is something that I configured in this application. If I want to know what my drop-off rates is between the steps of an online session, I can configure it in a funnel. So in Datadog, I configured a funnel saying, okay, I want to go from my business dashboard financial manager, how many sessions clicked on the accounts list, and of those sessions, how many people clicked on the card details, right? It's a flow. You online banking, you want to look into transactions. We can measure it, but how do we aggregate it? It took me a while to figure out and to basically reverse engineer all the calls of Datadog, but I managed to get a really reliable data out of there. And here you can see that I've got basically the same data. Now I have 10 sessions going into the dashboard financial services. 4 of them went to the accounts list, and 3 of them went into the business card list. Now, the plan is to configure this for all of the out-of-the-box journeys that we have within Backbase, and then we can run the same query to all our BaaS customers. And then we have an aggregated view of the performance of applications. And then we can also filter down on dates. We can figure out what the performance is in this particular date range. So it allows us to get all this information out of the system, basically. And with that is that's basically the conclusion of my research. So I hope I've shown you that I can collect all the information out of the different Datadog instances and then aggregate them into the data lake and then show the results inside Power BI. I'm also able to publish those results into an online service. And that allows me to also send the reports to other people interested into it. So you can have marketing departments look at the numbers. I can have create the reports and also expose the data set itself to all the different stakeholders. So if I go to Power BI, log in. Now we're going back into the cloud again, which is nice. And here you can see that here we've got the data set of the run bar, and this is the report that can be accessed by people everywhere in Backbase, basically. So really becoming, hopefully with this, we're getting more data driven and make better decisions, basically. Any questions so far?
Yeah, I actually do have a question. Well, first of all, thank you very much for this deep dive on the this impressive pipeline from RAM to bar. I think it's an awesome journey. I have a question about data ownership. You are in the financial space, or Backbase is in the financial space, and
yeah.
I have a question about data ownership, data anonymity. How do you respond to those such concerns when a client comes up to you?
So that is part of, so what I'm doing now is research. It's part of also, it's also part of the research to find an answer to that as well. So at the moment, all the stuff that I gather, all the dashboards that I create in Datadog are not exposing any of the personal information. The information that you see inside Datadog is only available to the teams running the bank that have clearance to view this information. I am carrying the database that does contain all the personal information. So I am also trying to figure out what steps, what anonymization steps I need to do to make sure that I'm not using any queries that can expose this personal information. Things like anonymous user information, like browser versions or geolocations, those things are fine. The bank will be the owner of the data, of course. So they have to give us consent, of course, to aggregate anonymous data.
Thank you very much.
You're welcome.
Marcos, do you have any questions from your side?
There is one question. Yeah, there is one question from the community, because Bart, all these amazing dashboards that you present in the Datadog, do you know if it's possible to create it and deploy them via, for example, Terraform, following up a little bit the previous talk from Roberto?
Yeah, that's a very good question. Yes, it's completely provisionable through Terraform. A lot of the Datadog, actually, this was also a requirement by our DevOps teams, because they don't want to go online and insert the same dashboard everywhere. They are running tens, many different environments. So for them, it's also key that they automate everything. Now, luckily, a dashboard definition in Datadog can be stored as JSON and can be provisioned using the API in the Terraform scripts. It's already built in the Terraform configs that are out there. Yeah.
Cool. Thank you very much, Bart. No more questions. Angel, come back to you.
Yep. Are there any questions here in the room? Maybe apologies, I haven't asked before in any other presentations, but I give you now the chance to ask any questions. Maybe Bert, you can explain what the picture is about, or where is it?
Well, this is because Europa in Asturias, of course. I think you would have recognized it.
I think Andres gave me the hint.
No, it's I've been to Asturias a couple of times, and I'm really liking the sidra that you can drink from those machines where you have this pouring high into the glass, putting a lot of oxygen in there. And I'm still looking for, I always like to make acronyms within Backbase, and the Rambar is one of them. But I'm also looking at an ILBAR that's basically giving an overview of all the legal entities. But I'm going to do my best to also include a Sidra bar, right? So I'm still looking for an acronym I'm very acronym driven. So I start with the acronym and then I'm going to figure out what it means. So I'm still working on the Sidra bar. I'm pretty close with the Aperol bar for the application performance environment. Still need to work on some letters, but yeah, it's I'm trying to build a bar in the Backbase Lake with all the liquor you can think of, but also have a real business value as well. Yeah, it's the best bar at the Backbase Data Lake.
Yeah, maybe Andres can give you also some other words for chigre. Maybe that's something for you to look up. He will explain. Thank you very much, Bert.
You're welcome.
I'd like to take over the screen sharing, if you don't mind,
yeah.
Real quick. I'm gonna wrap up the event. You're doing my screen. Before I finish, call for papers. We'll continue with more events, mixed events, online events. We'll have to see, but we hope for more mixed events like this one. We can bring the best of both worlds, like meeting people on site and also online. I think it's a great way of pushing or driving this community. And as I said, here we have a form. We have a call for papers. If you want to submit any presentation in any kind, any form, we'll be more than welcome to receive them. So yeah, please spread the word and help us to enhance this community. It's for professionals in Asturias. So yeah, more than welcome to receive any submissions. From my side, there's anything else? I would like to thank again all the speakers that we've had today, and also the great empathy team, Amplify, and the engineering team for giving us the opportunity to stay here with us today. With you today. And I don't know, Marcos, do you have any final words that you want to
yeah, the thing that you mentioned, Angel, thank you the speakers, and thank you all the attendees in virtual and also in person. Thank you very much, and be safe.
Andres, do you want to say something? Okay. All right. From my side, from our side, there is nothing else we can say. So thank you very much, and hope to see you next time.
Thank you. Have a lovely day. Bye-bye.
Thank you. Ciao.